Our goal is to factor trinomials of the form x squared plus bx plus c here. Notice that there's no a in front of this, or the a term is 1. It gets more complicated when there's something like a 5 in front of the x. So we'll start with no coefficient in front of the x and just start from there. And what we want to do here is factor polynomials into prime factors. So just like the number 6, for instance, well, that's 3 times 2, and these here are primes. Primes, okay, those are prime numbers. We can factor a polynomial, something like this, namely a trinomial in this case, x squared plus 6x plus 8, down into prime factors. Okay, and it turns out that these are x plus 4 and x plus 2. Now, we'll go into the method on how to find those factors, though, you know, in the best case scenario, you can eventually start to just look at these and factor them like this without using this diamond method that I'll demonstrate. But these here are prime factors, right? Prime factors. So just like numbers break down into prime numbers, trinomials can oftentimes break down into prime factors. Okay, so let's talk about this diamond method. The diamond method is a trick to help with this factoring process. And what you do is you draw an x like this. Some people call it the x method or the magic x. And there's a lot of variations on this. So this is just one particular method. And the c term goes here, the b term goes here. And then you do an x over, and then a factor goes here, and a factor goes here. Okay, so that's the general setup. And then our goal will be to find factors of factors of c that add to b. Find factors of c that add to b. Okay, and where are these c's and b's coming from? They come from here. There's our b and there's our c. Okay, so let's do an example and see how this works in action here. Okay, so let's try example here. Let's do that same example we already factored. Let's do x squared plus 6x plus 8, just to show how it's done with the diamond method here. Okay, we draw our x. Okay, so 6 is our b, 8 is our c. So 8 goes up here, 6 goes down here. I do this x over business. You'll see why, but it's especially necessary to do that when you get to factoring these trinomials that have a term that's not 0 up here. Okay, so we want to find factors of 8, so factors of c that add to b, that add to 6. Okay, so let's start listing the factors of 8. All right, so we have 1 times 8, that's 8. 2 times 4, aha. This is what we're looking for, because 2 times 4 is 8, but 2 plus 4 is 6. So factors of 8 that add to 6, we found the one that we're looking for. And if that wasn't it, we keep listing these until we found one that works. If none of them work, we would say that the trinomial in this case is prime. All right, so this works. So we put a 2 here and a 4 here. And this is positive. These are both positive, so we kind of look at it like this. This will be x plus 2 times x plus 4 for our factorization here. X plus 2, x plus 4. And there is our prime factorization, same as up here. And you can check this by foiling, right? So You don't always have to. If you've done it correctly, your answer will be correct. But sometimes it's helpful to check it by FOILing. First outside, inside, last. Okay, so I'll do that here. We have x squared first, outside plus 4x, inside plus 2x, and last plus 8. Indeed gives us our original trinomial back, x squared plus 6x plus 8. So it checks out. That's how you do the method.